Hey, all you cool cats and kittens. Sorry about that. It's Mr. Flynn here. I received a lot of questions from you about number 5 on the A10 completing the square practice. Um, I just wanted to address it, do the problem out, and explain why the answer is written down the way it is and why you may not have gotten that answer. So the original problem is 3x squared minus 12x minus 32 equals 0. Okay, so I'm going to go through this problem assuming that you have done all the notes, you know what you're doing, or you kind of know what you're doing, and you've attempted this. So um, if you have any questions about what I'm doing, make sure you contact me or you reference your notes. So first thing I'm going to do when I'm completing the square, I'm going to take my C term and I'm going to add or subtract it over to the other side of the equal sign. So it was minus 32, so to cancel that out, I will add 32. Okay, when I do that, negative 32 plus 32 cancels out. I get 3x squared minus 12x equals positive 32. Okay, so that's our first step when we complete the square. For our second step, I'm going to take a look at my a term. So a is going to be the coefficient of your quadratic term, quadratic meaning an exponent of 2. This needs to be 1 in order to complete the square. Right now, I've got a 3 here. So to get rid of that 3, I'm going to divide everything by 3. All right, so when I do that, these 3's are going to cancel. So I've got x squared. Negative 12 divided by 3 is going to be minus 4x equals 32 over 3. I can't simplify, so I'll just leave it as 32 over 3. Okay. So next what I'm going to do is I'm going to set it up so I can actually complete the square, complete the perfect square trinomial. So in order to do that, I am going to rewrite my equation, but I'm going to set up some blanks here. So I've got x squared minus 4x plus blank equals 32 over 3 plus blank. Okay, remember, whatever you do to one side, you have to do the other during this process. So now what I'm going to do is I'm going to take my b term, which is negative 4. Remember, I have to divide by 2 to get the magic number and then square that magic number to fill in the blank. So first thing I'm going to do is divide by 2. So negative 4 divided by 2 is going to be negative 2. Okay, and what I'm going to do is I'm just going to highlight over this. Okay, because this is going to be my magic number. When I end up factoring the left side, I'm going to use this minus 2. Okay, so I've got this, my magic number. I have to square it in order to fill in the blanks. So negative 2 to the second power is going to be positive 4. So this positive 4 is going to be plugged into that blank right there and that blank right there. Okay. So at this point, on the left side, you should have x squared minus 4x plus 4, and on the right side, you should have 32 over 3 plus 4. Okay, so what I'm going to do is I'm going to move right up here. I can factor the left side, and this is a scenario where I could use the AC method if I wanted to. But the reason we use this magic number is we're not always going to be able to do the AC method, where we could have some fractions in there. We could have some numbers that could make it really confusing. So I think it's just easiest to use the magic number, a little shortcut. But if you did want to try to use the AC method, you would get the same answer. So using my magic number, I know I can create a set of parentheses. And because the left side is a perfect square trinomial, I can put my variable, which is x, and then plug in my magic number, which was negative 2, so minus 2. Okay, squared equals 32 over 3 plus 4. So remember, we're adding fractions here, so we need a common denominator. Okay, so this 4 is the same thing as 4 over 1. So common denominator, looking at my 3 and my 1, I know it's going to be 3. So what I will do is I will multiply the top and the bottom by 3. So if I continue down with my process here, I've got x minus 2 squared equals 32 over 3 plus 4 times 3 is 12 over 1 times 3 is 3. So continuing down with this process, I end up getting x minus 2 to the second power equals, I know I'm going to have a denominator of 3, and 32 plus 12 is going to be 44. Okay, so I don't think a lot of you had issues at this point. What you're going to do now is you need to get rid of this squared, or the second power, the exponent of 2. So in order to undo that, or to get rid of it, we will take the square root. And whatever we do to one side, we have to do to the other. So what I end up getting here is going to be x minus 2 equals plus or minus the square root of 44 over 3. All right, so now our last step, we will add 2 to both sides. When we do that, 2's cancel, so we get x equals positive 2 plus or minus the square root of 44 over 3. Okay, so I think a lot of you had this answer right here. If you did your steps correctly, you should get x equals 2 plus or minus the square root of 44 over 3. But if you were to look at your answer key, you don't exactly get that. You end up something with the square root of 33. Mass confusion breaks out, panic, maybe you flipped a car over, I don't know. But let's talk about this right now. So you might remember from earlier in the year, let me get off onto a different screen here. You might remember from earlier in the year, we did A6. So I've got the A6 rubric right here. So you might remember that in level 1, you can write radicals in exponent form or write rational exponents in radical form. Okay. The first line here and the last line we skipped over briefly because I was going to do it as part of level 3. Level 2, we simplified radicals, and remember, if the index was 2, we were trying to find pairs. If the index was 3, and by index, what I'm referring to is the little number on the outside of the radical, that told you how big your group needed to be in order to pull something out. You might also remember that once we finished level 2, we went straight to A7. And I said at the end of the year, we would come back and we would do level 3 and level 4, which is level 3, you can rationalize the denominator involving any radical, and level 4, you can solve radical equations involving 2 radicals. So we were happy with that. We did A6. We took a summative that was only out of 60 points. You can check back on Infinite Campus and take a look at that. We headed on to A7. We did A8. We did A9. And then this whole COVID-19 broke out. So it was my intention for the honors class, if we could get there, but even the CP class, if we finished all our standards maybe a little bit early, to come back and do levels 3 and level 4. And why I wanted to save it for the end of the year is because it is a skill that you start pre-calculus with. And I'm assuming that all the honors algebra 2 students will be going to pre-calculus next year. Okay, just an assumption there. So level 3 and level 4 were saved for the end of the year. I think if we were in school right now, we would currently be working on level 3 and level 4 for honors algebra 2 at least at the pace we were going, because we were going at hyperspeed. Unfortunately, we didn't get there, okay? And this level 3, the rationalizing the denominator, kind of explains why there were some differences in answers for number 5 for A10 completing the square, the problem that we just did. So what I'm going to do is I'm going to give you a quick crash course for that specific problem that we just did on how to get the correct answer and how to actually rationalize. So you might need to dig deep into your brain here and think back to A6 and all the skills we learned there. So I'm going to go back to my screen. Okay, remember we got this answer right here. Okay, so what I am going to do is I'm going to rewrite it down here. So I've got 2 plus or minus the square root of 44 over 3. So when we take a look at this answer, this 2 is fine. We're really not going to do anything with this 2. But when I take a look at my radical here, I've got this fraction 44 over 3 underneath my radical. Okay, so the rules of radicals tell us that we can rewrite this square root of 44 over 3 as two separate radicals. So we've got the square root of 44 up top, and we've got the square root of 3 down bottom. Okay, so all I did was rewrite it here. I took this one big radical and I broke it into two smaller radicals, one the numerator, one the denominator. Okay, so I think we'd all be all set there. So taking a look at this, in math, this is actually not allowed. Okay, and the reason this is not allowed is because of this square root of 3 down bottom. Okay, and it's not allowed because if you think of fractions, fractions are something that we can write as a ratio. Okay, they're rational numbers. The square root of 3, if you were to type that into a calculator, that's not a rational number. That's an irrational number. That's what that's called. Okay, so because this is an irrational number and this is not technically written as a ratio, we need to get rid of this square root in the denominator. Okay, so in order to get rid of that square root in the denominator, remember when we were simplifying radicals, if we had an index of 2, so this has an index of 2, remember, because it appears as if there's no number out here. There's no 3, there's no 4, there's no 5. If it has an index of 2, we need a pair of some number underneath the radical or variable in order to pull something out. Okay? So when you're faced with this situation here where you do have a square root in the denominator, this is called, you need to use a process called rationalizing in order to get rid of the radical. So I've got the square root of 3. I've got 1 3 underneath the radical. If I had another 3 underneath there, I would be all set. I'd be able to take the pair of 3's, pull it right out, and I would not need to have my square root symbol here. Okay? So what I'm going to do is I'm going to scale this equation, or scale these radicals by radical 3 over radical 3. Okay, so it's awfully similar, I would say, to finding a common denominator. Okay, we're scaling this fraction by another fraction that is equal to 1. Square root of 3 divided by the square root of 3 is equal to 1 in order to get some desired numbers or some desired results. So if we do this here, the square root of 44 times the square root of 3, okay? What I am going to do is I'll draw my fraction bar, but I'm going to break down the square root of 44 first. So remember the square root of 44, going up here, we can rewrite as the square root of 4 times 11, which is the same thing as the square root of 2 times 11. Looky here, we've got a pair of 2's that we can pull out. So the square root of 44 can actually be rewritten as 2 square root of 11. So I'm going to put that in my numerator, okay? And I'm multiplying by the square root of 3. Now down bottom, I'm going to do the same thing. If we've got expressions that are under radicals, okay, as long as their index is the same, we can multiply whatever is underneath the radical. Okay, so I've got the square root of 3 times the square root of 3. I'm going to put that all under one radical. Okay? So this typically, once you start doing rationalizing problems like this, you probably wouldn't write out this step like I have. But I just want to be clear. Again, I typically tend to be more thorough as opposed to less thorough. So what I'm going to do now is down here, I am going to multiply my numerator, or simplify my numerator. So the rules of radicals state that we can multiply numbers that are outside of the radicals together, and we can multiply the numbers that are inside the radicals, given that they have the same index together. So I've got a 2 on the outside, and I've got, like an imaginary 1 here. So I know I'm going to have a 2 on the outside. Now underneath my radical, I've got 11 and 3. Their index is both 2, so I can multiply these two numbers. So 11 times 3 is going to be 33. Okay? Now, if we could simplify the square root of 33, we would, but the square root of 33, we'd end up with 3 and 11 as factors, and we're not going to get any pairs. So this is fine as is right here. So now down bottom, using our simplifying radical rules, Index is 2. We've got 2 3's underneath the radical. So we know that we can pull a 3 out, kind of like we did with the 2's up here. So I've got 3 on the outside of the radical. I'm left with nothing on the inside of the radical. So I don't need to put a radical. So if you take a look here, this is an acceptable fraction because I no longer have a square root in the denominator. All right. So now if I move even further over here, I've got my final answer up here. I'm going to rewrite as x equals 2 plus or minus 2 square root of 33 all over 3. So this is a good answer. Okay, that is an acceptable answer. So now, what I think some of you are going to say is you're going to take a look at your answer sheet for completing the square, and then you're going to take a look at this answer and go, Mr. Flynn, you did it all wrong. It looks a little bit better, but this is not the answer that is on the completing the square worksheet. Okay? And I know that's not the answer on the completing the square worksheet, but it's actually the same answer as this. So let me explain that. If you take a look, we've got 2 terms here. We've got this 2 right here all by itself. Now we've got plus or minus, and we've got 2 square root of 33 all over 3. So we've got 2 separate terms, plus or minus. Whenever we've got fractions and we're adding or subtracting, as we are here, because remember this is 2 different answers, we need to have a common denominator. So again, I'm completely fine with this answer, but the answer sheet went an extra step here. So if I take a look at my denominator here, I've got a 3, but it is just under the 2 square root of 33. It's not under this 2 over here. It's just under 2 square root of 33. So what your answer sheet actually did is it put a 3 underneath everything in the numerator. So this 2 right here, I believe, is actually a 6. And the reason behind that is because, you rewrite it here, we know 2 is the same thing as 2 over 1. I hope that makes sense. Plus or minus 2 square root of 33 over 3. You switch colors here. Because we're adding or subtracting, you need a common denominator. Taking a look, 3 and 1, it's going to be 3. So I'll multiply by 3, multiply by 3. So we end up getting x equals 2 times 3 is 6. 1 times 3 is 3. Plus or minus 2 square root of 33 all over 3. Okay? So the last step here, we've got 2 fractions, okay? 6 over 3 and 2 square root of 33 over 3. What the answer key did is they just set it as one fraction. They kind of combine these 2 things together. So in the numerator, it has 6 that I got from this fraction, plus or minus 2 square root of 33 all over just 1 3 here. So this is an acceptable answer. There is nothing wrong with this answer. Just the answer key, it's not going to have 2 separate answers. Okay, it's not going to have 2 different answers. So as long as you can recognize that this is the same thing as this, or you had one of those answers, you're completely all set. Okay. If you have any questions about this, completing the square, I will say, is probably, it's a shame we can't do it together. It's probably my favorite thing that we do all year, especially the transition from completing the square to the quadratic formula. It's hard to get passionate about that, but I swear I'm passionate about it. So if you have questions about this, I realize it's dense. None of the math in particular is very difficult, but it's a lot of steps that you're putting together. I mean, hey, take a look at this. I'm not sure how long this video has been now, but we've only done one problem. That's quite a bit of work, or quite a bit of time put into one problem. So please let me know. Please reach out if you have any concerns about this. If not, I hope this made sense. If it doesn't make sense, or you'd like some additional practice, some supplemental material to go over rationalizing, or the level 4, I'd be more than happy to do that for you. In the meantime, I hope you're enjoying yourself, thinking of you every day. I miss you all. Hope you're staying safe and these times aren't too difficult on you or your family. Talk to you soon. Goodbye.